There we go. So for our, apparently I can't click on this question mark.
Ms. Paulson, please go to 2D5. Ms. Paulson, please go to your class. Thank you.
So a composite function is when you have one function inside of another function. And the example that they have here is a vehicle. And for a vehicle, there is a cost of gasoline. Unless you have an electric vehicle, then there's a cost of electricity. And so you can make a function for that the cost depends on how much gasoline you buy, based on the volume. You buy 10 liters, it costs you a certain amount of money. You buy 20 liters, it costs you more. Then there's also a function that the amount of liters you use depends on how far you drive. And different vehicles have different fuel efficiencies. So you might have, do any of you have a car that actually tells you this? You're driving like 12.2, you're using 12.2 liters every 100 kilometers. It gives you information. So the amount of liters used depends on how much you drive. But inevitably, you want to figure out not both of those things separately, but if I take a road trip, where are we going to go? Calgary, somewhere far. How much is that going to cost me? And so I have to put both of those things together, that my cost is based on my volume, which is based on the distance. So if I know the distance, I could calculate the volume, and I could calculate the cost, but I could also combine these two to get an equation that just puts the distance in and tells me approximately how much money I'm going to spend on gasoline getting to Calgary. And guarantee, once you've started doing some more road trips, you're going to start calculating these kind of things. So this is the composition of function. This and composition of function, just like this is my favorite notation, and it also has another notation that's not as clear. And it's kind of funny, this one that's not as clear spells the word fog. Just by pure coincidence. So if I have the foggy notation, right, if someone said, what's f of g of 2, I would change this to write it this way, as f of g of 2. And really what this means, when you have f of g of 2, if we think back to our fraction machines at the beginning, this would mean that first, composition of functions, you can always think of the image of two machines with the conveyor belt in between. Now you're not, whoa, that machine's a little bit long. Okay? F of g of 2 would be saying, I'm going to put 2 into g of x first. Something's going to come out. What's going to come out is whatever g of 2 is. G of 2, that answer is going to go on a conveyor belt and then go into f of x. And an answer is going to come out after that. So when you put a number into the composition of functions, it goes into the inside function first. So when you think about two machines happening, one after another, f of g of 2, first 2 would go into g of x. You would get an answer, and whatever answer you get goes on that conveyor belt and then falls into the f machines, into f of x, into that function, and we get an answer. Not crazy hard once you know what you're doing, but the notation itself might be new and a little bit confusing. So let's look at some questions. We'll look at them. We'll look at the same idea over and over again. Here's example 1. You want to find g of f of 2. So visually, this means that first you're going to plug 2 into f. If you plug 2 into f, can you see that out would come 0? Okay. Now, you're not going to draw this each time, but for right now as a visual, right, if you think of two machines, one right after another, first you're putting something into f of x, then you're putting something into g of x. And we're plugging in 2. If you plug 2 into f of x, out would come 0. And then you would plug 0 into g of x, what would come out? 1. Okay? So now, you're not going to want to draw little tiny machines all the time. How do we write this out? Well, we would say g of f of 2 is the same as g of 0. And then g of 0, that's equal to 1. But we work from our inside function first, get that answer, and then work with the outside function. So you can even have the same, you could buy two machines of the same kind and stick them together. G of 2, do the inside first. What is g of 2? Go along here. If I plug 2 into g of x, out would come a minus 1. And then what's g of minus 1? 2. So g of 2 is still equal to 2. What would g of 2 be? 2. And if I added another g of?
-1.
It'd be -1. You see, if it was an even number, out would come 2 again? Because it just keeps flip-flopping. 2, then -1, then 2, then -1, then 2, then -1, then 2, then -1, then 2, then -1. So if there's an odd number, it's going to be -1. If there's an even number, this one is going to be 2. You definitely wouldn't want to draw all the machines. Take you for a long time to do that. Okay, so circle question number 4.